Welcome to Chapter 3, Section 2. We're looking at properties of parallel lines. These postulates and theorems are going to be very, very important to you. They involve the special angles, and what they also involve, though, is what happens when the lines are parallel and they're crossed by a transversal. So something that wasn't mentioned in the first video, but it is important. When we want to denote that two lines in a picture are parallel, we put arrows on them. And those can be solid arrows like I've drawn here, or you could choose to draw the arrows open, okay? And so that's how we denote that two lines are parallel. So the first postulate says, if a transversal intersects two parallel lines, the same side interior angles are supplementary. Remember, you're looking for a C, and remember, your same side interior angles are supplementary. There's a lot of alliteration going on there, and that makes it easier to remember. Same side, supplementary. So in the picture, we can see that angle 1 and angle 5, the same side interior angles, are supplementary. Angle 2 and angle 6 are supplementary. And again, there's no symbol for supplementary. The next theorem is for alternate interior angles, and it says, again, when the transversal intersects your two parallel lines, your alternate interior angles are congruent. So remember again, the shape we're looking for is a zigzag shape. So in our picture, if line K and line M are parallel, then angle 1 must be congruent to angle 6, and angle 5 must be congruent to angle 2. The next theorem is the corresponding angles theorem. Again, when that transversal crosses your two parallel lines, your corresponding angles will be congruent. Remember, the shape we're looking for corresponding angles is the F. So in the picture, we've got a lot of marks to make here. Angle 3 turns out to be congruent to angle 5. We also know that angle 1 will turn out to be congruent to angle 7. Now I also want you to take a look. We have vertical angles going on here, so it's only logical that angle 2, the vertical angle from angle 3, ends up congruent to angle 8. And also we can see that angle 4 ends up congruent to angle 6. So I use different colors to show that, but again, the markings tell us that angle 1 and angle 4 are congruent, and we know that's true also from vertical angles are congruent. Okay, so here are your corresponding angles are congruent. When you're using these reasons in proofs, you are welcome to say same side interior angle postulate, so you can name it, or you are also welcome to say same side interior angles are supplementary. For the alternate interior angles, you can say alternate interior angle theorem, or you can say that if lines are parallel, alternate interior angles are congruent. You'll remember from last section, the lines don't have to be parallel for the alternate interior angles to exist. So same thing here, we would want to say if two parallel lines, then same side interior supplementary. If lines parallel, alternate interior angles congruent, and if lines parallel, corresponding angles congruent. It may be easier to just name them by the title of the theorem. Okay, let's move on to page 2. Okay, on page 2, you have the last theorem for this section. It is the alternate exterior angle theorem. Again, the best way to use it is to go by its name of the alternate exterior angle theorem. And so, I'm just going to highlight that. Again, alternating exterior angles, it says here that angle 3 will be congruent to angle 8, and it also tells us that angle 7 will be congruent to angle 4. Alternate exterior angles are congruent. Again, this is not necessarily a theorem that you need because you could get by with the 3 ideas that are on page 1 of this packet. Okay, we're going to do one more example on page 3, and then all the rest of the examples we'll do in class. Okay, we're on page 3 of the chapter 3 section 2 packet, and we're working on the first example, and we're told that A is parallel to B. So when we look at our picture, here's line A, here's line B, and again we mark that they're parallel by adding arrows to the picture to say that those two lines are parallel. Sometimes what I also like to do, just to help myself see in the picture what's going on, is I will take a highlighter and lines that are parallel to each other, I will color them the same color so that I know those are the parallel lines, and any line that's not that color is acting as the transversal. So if we take a look on this page, we can see that we have one transversal and we have a second transversal. So we're being told that angle 5 is equal to 40. Again, you should always write that in your picture. And we're being told that angle 4 is equal to 30. So we're going to write that in the picture also. Okay, so once we have those marks, we can go ahead and start filling in. And sometimes you're just using old information and not necessarily anything new about parallel lines. For example, right here in this group of 4, if this angle is 40, angle 7 must also be 40 because vertical angles are congruent. I also know angle 8 must be 140, and I know that's true because linear pairs are supplementary. So again, that's old stuff. Nothing new going on here. And then of course vertical angles again will get us that angle 6 must also be 140, or linear pairs, whichever way strikes you. When we move across to this other group where the 30-degree angle is, I can apply the same principles and make angle 2 be 30 by vertical angles. Angle 1, 150, linear pairs are supplementary. And angle 3 by linear pairs or by vertical angles will also be 150. Okay, at this point we've kind of exhausted everything we can using old information, linear pairs and vertical angles. I now need to bring in the new information with the parallel lines. So I take a look at this and I look at angle 9 and I start to look. Remember, you're looking for Z's, C's, and F's because those are the alternate interiors, the same side interiors, and the correspondings. And my personal favorites are the alternate interiors. So I look at angle 9 and I say, okay, I start the Z and I can see that angle 5 down here finishes the Z. In which case, what's angle 9 going to be? That's right, it's going to be 40 because alternate interior angle theorem. If the lines are parallel and they're cut by a transversal, the alternate interior angles will be congruent. Okay, then I go over to angle 11 and same thing. For angle 11, I'm like, all right, here's the start of angle 11. I'm trying to see if I can get that zigzag action going. And if we look right here, we've got a backward Z happening with those two angles, and therefore angle 11 will be 30 because of the alternate interior angle theorem, which says again, two parallel lines cut by a transversal, alternate interior angles are congruent. At this point, the last angle we need to fill in is angle 10, and we're going to go to old information for that. I know that the sum of these three angles must be 180, and therefore angle 10 must be 110 by subtracting from 180. Okay, that's the last example we're doing together. The rest of the examples will complete together in class. So have a great day, and I'll see you in class. Bye.